All right, so as we talk more about AI and machine learning and statistical modeling, it's important to remember that these tools can be incredibly powerful when they're used appropriately, but incredibly dangerous when they aren't. Now, the thing about tools like this key influencer visual here is that they're great because they help make machine learning accessible to everyday users, but a little scary because those same users often lack the foundational knowledge to understand what's happening behind the curtain and how to properly interpret the results or make intelligent decisions based on them. So, speaking of interpreting results, I think this is a good time to take a step back, take a pause, and review one of the most important rules in statistics and analytics. Correlation does not imply causation. Now, I'm sure many of you have heard this before, especially if you work in data or analytics, but let's take 2 minutes and break this down. Correlation is when two variables, x and y, move together, kind of like this. They move in the same direction. Causation, on the other hand, is when variable x causes variable y. In other words, there's a clear cause and effect relationship here. Now, what if I were to show you a scatter plot like this? We're plotting violent crime rate on the y-axis and some mystery variable on the x. And based on this 25, 30 observations here, we've got a very tight correlation, pretty clear linear relationship between the two variables. So clearly they move in the same direction, clearly they're correlated, but you might be tempted to think, that this x-axis variable is the driver behind violent crimes. It's causing violent crimes, and that if only we could cut back on whatever this variable is, we might be able to make our streets safer. The problem with that is that we're looking at ice cream cones sold. And you may be scratching your head, you may be a little confused, and that's totally understandable because the human brain is biased to look for cause and effect relationships where in fact they don't exist. So if you're still wondering kind of what's going on here and how this could possibly be true, here's a hint. Our y-axis, violent crime rate, could just as easily be drowning deaths, or forest fires, or even your dreaded crab attack. So think about what those things have in common, and you'll probably start to realize that this has nothing to do with ice cream at all, and everything to do with temperature. As temperatures rise, you have more people out later, gathering in public spaces. As a result, crime rates increase. You also have more people going to the beach and swimming in the ocean, so drowning deaths increase, and so on and so forth. So because ice cream sales are such a close proxy to temperature, we've created a false narrative that paints a completely misleading story. So key takeaways here: ice cream does not turn you into a violent criminal, it does not make you drown, it does not start forest fires, and it certainly does not encourage crabs to attack you. Now, obviously, these are silly examples here, but the core principle, the concept, holds true, and it's a really important one to keep in mind. I'll leave you with one kind of more real-world business case here. Should be a scenario like this. Maybe you run a startup, you've been live for about 4 months, and you're plotting your weekly marketing spend, which you've been ramping up, against your total revenue. Now, if you were to imply causation based on this chart, these results here, you might think that ramping up your marketing spend is a surefire way to drive more revenue. And that may be the case, it may be true, but it also may not. So the idea is you've got to think about the other factors that might be at play here. Maybe over this 3 or 4 month period, you've also been ramping up a new sales team, or maybe your organic traffic has been growing due to referrals or PR or something like that. So bottom line here, be thoughtful about how you interpret these results, and please use caution before you make big decisions based on these findings.